we're going to talk about sockets. And we're going to write a web server using sockets. So what is happening here? So the first thing I want to talk about is to point out that every web server uses sockets. So if you're using Rails, using Django, using Node.js, whatever, Java, doesn't matter the programming language, you're using sockets. So in principle, like to write a web server using sockets, all you have to do is write a web server in literally any programming language, and then you're using sockets. But obviously, that's not the point here. The idea is that we're going to write a web server from scratch with like the raw socket interface in Python. So we're going to be like import socket, and then we're going to go from there. We're not going to use any libraries except insofar as like the socket module is a library, but it's built into Python. So to start out, we're going to very briefly, what is a socket? I think it's going to be easier to understand what a socket is by actually using the socket module in Python. And like actually writing a little bit of code, not too much code, just a little. But let's talk about the basics a little bit. So we're going to be working with TCP sockets in this case, and the TCP protocol is the way that basically most of the information gets sent on the internet. So if you're using the web, you're getting a website. What happens is there's these computers, they send lots of packets back and forth, right? The first 3 packets in any TCP any TCP connection is like SYN, ACK, SYNAX. There's lots more packets. We're not going to go into the details of the TCP protocol today because it's a lot. But the point is that sockets are an abstraction on top of the TCP protocol. And the kind of abstraction layers, like if you've used something like Rails, are like you have the TCP protocol, which is like there's all these packets that get sent back and forth as sockets, which is what we're going to talk about, which like simplify it a little bit, so you don't need to think about all the details so much. And then on top of that, you have something like Rails or like whatever web framework you're using, which is what you'll use in practice usually when you're making a web server. And the basic TCP socket interface, I think the most important part is you have a connection, right, where you're connected to some other computer. And the interface is that you can send and receive data. So you say like, hey, I would like to receive some data from the other person I'm connected to. And the operating system is like, sweet, here is a string of like what they sent you. And then you can send data back. And so that's the whole thing. You send data, you receive data. For an HTTP connection, there's usually there is just one request and one response. So if you're a server, you'll receive data, the request, and then you'll send back a response. And if you're a client, you'll send a request, and then you'll receive back a response. So they'll just be sort of like one send and one receive. It can be a little more complicated than that in practice, because you might, even if there's just one response, you might need to receive the data in multiple chunks if it's like a big upload. But for now, and especially in this like little server example we're doing, where the like payloads we're sending back and forth are very, very small, we can say there's just one send and one receive, and the order just depends on whether you're the client or the server. So, and an example of like what concretely you might be sent or received in an HTTP connection is if you're the server, you'll receive something like get/cats.png http/1.1, which is what an HTTP request looks like, and then you'll send back a string, which is the response. So that's all of the background that we're going to discuss, and we're going to get right to writing code and writing a server. And we're going to use this Python socket module, and the reason that I'm using this to do this is that it's basically the same as using sockets in C. So it's sort of like almost the lowest level thing you can do. It's just that we're going to use Python because Python is like easier than C to write. It takes less time for me, at least. And the documentation for the Python socket module really looks a lot like reading the documentation for like sockets in C. All right. So import socket. That's where we're going to start out. We are going to write a server. I very, very quickly did want to write a client because that's simpler, and it's going to be like 5 lines of code. So we're going to see what it looks like to connect to make a connection using the socket module and to just get a web page. All right. So I made my file connect.py. Let me just full screen this, and we're going to do import socket, and then I think we need to create our socket with socket.socket, and then we're going to make a connection. So to make a connection, you need an IP address and a port. because every connection needs to be made to a port with TCP. That's how it works. And we're going to be using example.com. And so this is the IP address for example.com, apparently. So we can do s.connect, and then we're going to put the IP address. We're going to connect on port 80 because that's the HTTP port, AT. And then we're going to send some data. So we're going to just request like the homepage of example.com. And I've written this out a lot of times, which is like just like a weird fact about me that I know how to write out like an HTTP request. But get HTTP.1 host example.com. Put some new lines at the end. You always need to put /r. And we're gonna get some data back. And let's see if I type that out right. All right, is that right? I will be shocked if it is. Great. I'm missing a paren. Yeah. I'm using Python 3, and so it gets a little more serious about bytes and strings, but we did it. So what happened there is we connected to example.com, and we got a web page back. This is a web page. Yeah. That's it. You can see there's a bunch of HTML in here. It's like HTTP 1.1 200 OK. So we have used sockets to make an HTTP connection, and all we had to do was be like, let's create the socket, connect to this IP address and port, send this request, and receive the response. And like when you're making HTTP requests in real life, like what I don't know, curl or like Firefox is doing behind the scenes is really this. Like it's not a lot more complicated than this. It kind of is because usually you're using TLS, so everything's encrypted, which is a whole other layer. But this is really the basics of what's happening. And it's like 3 lines of code, right? 4 lines of code, which I think is really lovely. But that's all we're going to do about a client. We're done with being a client. We want to be a server, which is much more interesting. And I pre-wrote some of the code here just to start us out. We're going to write another maybe like 15 lines to flesh out this server. And so to start out, we have we're going to make the socket, and every server has a port that it's listening on. And so like, yeah. So in this example, the port that we're listening on is port 8080. Because that was just what I picked. I could have picked anything. And so we need to say like, hey, bind this socket to this port. And then we say to start listening. This is number 10 here. I might get into it later. This is basically asking the operating system like, hey, if I'm not available to handle a connection and there's extra connections waiting, you can keep at most 10 connections like in a backlog. And this is like a required parameter, so I had to put it in. And we'll see if we get to this. But I just made 10 kind of an arbitrary number. I don't know if it's the best choice. And then we accept a connection, because here you just have a server, and this isn't yet like a specific connection to a client. So, and we might wait a long time here for like to actually get this connection. And then once we get a connection. So here we wait for a connection, right? That's what's happening. These things all happen right away when the program starts. But this might happen like 10 minutes later because it's going to stop here for a long time. All right. And then once we get our connection, we're just going to print out what we got. So this is like, here we have the connection. So here's where we do send and receive, right? And after we run this, we're going to then be like con.send, and we're going to send the response. But we won't do that right now. So let's start the server, server.py, and I know that that's listening on port 8080, so I can just do curl localhost 8080, and it says empty reply from server. This is because we didn't really send a response or anything, right? But we do see that it did print out the request, right? So we got this request from curl, and it got printed out. All right, so I tried to start up the server again, and something bad happened, which is it was like address already in use. And honestly, I'm going to pretend like I immediately knew what was going on. But when I first saw this error, and I was preparing this. It took me literally like 45 minutes to understand what I'd done wrong to get this error. So I'm gonna do something really quick right now to fix it. But it took me like a while to figure it out. Basically, what's happening here is if we do netstat -t or something, sudo net /-t. Sorry. Grep 8080. What was I doing? Anyway, the issue here is that there's a process, a connection, which basically we didn't close our socket. And the operating system kind of thinks it's still open and that this port is still being used. And eventually, after some time passes, it will realize that everything is okay. But we do need to close this socket and this connection for everything to be okay. And I think we're going to shut down the socket just to be extra sure. So how does this work? It says in the docs. We can do like con.shutdown. And maybe we can do shut read write because it has this parameter that it wants. All right. So we have a bunch of new stuff to shut down the server after it runs. And the reason that now it let us start it is basically that it was like, okay, I guess this server is gone now. And I'll forget that address wasn't used, so it can be reused. And now if we do curl, and we try to start the server again, it still doesn't work. Cool. Wonderful. Why is that? Okay. So I spent a bunch more time looking at this and trying to figure out why it was like address already in use. And then I finally thought of looking at the docs, where it's like, hey, if you're getting this error already in use, that's because the previous execution has left the socket in a time wait state, which is something that I had seen. And you need to set this SO reuse adder socket flag. And so let's just grab this and put it into our code here where it says in between setting up the socket and bind. And if we run our server and then we do like a curl, then we run our server again, it works properly. Everything is beautiful. And we can move on to doing something more interesting than just listening on a port. So the next thing we want to do is we want to send an HTTP response, right? Because it's more interesting to actually like send a response from our server. So I'm just going to write out an HTTP response. I think to start out, I'm just going to send the string hi there. So it's going to be 200 OK. And then content length. I think it's always good to set content length. It might be 10 or something. How long is this? That's something like 10 characters. All right. So there's some kind of HTTP response that curl will accept. And then we can send, and this should be bytes and not a Unicode string, because that's what this Python module wants. And then we're just going to send this HTTP response. All right. So if we run our server and do curl now, it says, hi there. Is that right? That seems reasonable. Let's just see what happens if we go to localhost 8080 in our browser. This is not right. It should just say hi there. It shouldn't say 200 OK, content like 10 hi there. That's not right at all. So that's kind of interesting. Okay, the first thing I'm going to do is I'm actually going to put a while loop here so that we can serve more than one connection, because that's going to be more interesting. So we're going to accept a connection, and then we're going to receive its request, and then we're going to send the response in a loop. And then we're going to close the connection. Okay, so let's just try to see what's happening and like why this isn't working quite right. Okay, so what we're gonna do is I'm gonna do curl example.com -v, and I'm just gonna see. Yeah, exactly. This is because I forgot how to write an HTTP response. So it actually starts with HTTP 1.1 200 OK. So let's do that instead. Let's restart our server. Oops, and then we'll do curl localhost. Okay, and then it just says hi there, which is the actual content of our response. And if we go in our browser, we can just see that it says hi there. So now we've written a web server, right? Like we've sort of finished what we set out to do, which is to write a web server. But there are a few more interesting things that we can do that are not just like return the string hi there. Well, they're actually still going to be just return the string hi there. But we're going to do it with threads. So the kind of interesting thing here, right, is let's imagine that this request took a little bit longer to return. So let's say that like for some reason we need to do some like slow computation and it takes like half a second, let's say, to send this response. So that's fine, right? And I made this little test script that just simulates getting 5 simultaneous requests. So we're going to run it. We're going to see what happens if 5 requests get sent at the same time. And what happens is that it gets sent 5 requests, and then it needs to sort of like in a loop send each of the responses back. And so the last person actually needs to wait 2.5 seconds, right? Like all of these requests got sent right away, but the last person had to wait like 3 seconds to get the response back because our server wasn't sending responses in parallel. And that's no good. So let's make it send responses in parallel. I'm going to need to look at the docs again. We're going to use threads. So there's this thread module in Python that's, again, like part of the core. And how does this go? Oh, we're all the way at step 3, handle multiple connections at a time. Yeah, because right now we're only really able to handle 1 connection at a time. Oh, but no, there's one more interesting thing we should see about this before we do the smart thing and handle 1 more connection at a time, which is that we should see what happens if we try to make 15 connections at a time. So is it fine? Oh, it's fine. Okay, that's interesting. I thought that it might get mad because of the backlog, because it can't, like, there are more than 10 connections that are waiting for our server. What if we reduce this to 1? Is that still fine? That's still fine. Okay, well, obviously the backlog isn't doing what I think it's doing, and it's doing something else. Because this thing is able to keep like 15 connections in its waiting pool just fine. There might actually be a minimum which is bigger than 15. I'm not sure. All right. Well, let's move on and parallelize this so that the behavior is better than this, right? Because with 15, this person's having to wait 7 seconds for the HTTP response. It's no good. You can't have a single-threaded web server. I mean, yeah, there definitely needs to be more than 1 thread. All right. So all we need from this thread module is this thread.startNewThread function. So just copy that. And so what we're going to do is we're going to define what we do when we respond to a connection. And then we're going to do start new thread of respond, and this connection object is what we're going to send. And then everything in here can just go into respond. So this is sort of our main loop, is we just wait for connections, and then we start a thread to respond to the connection, and then we just go straight back to waiting for a connection. So let's see if this worked and what happens. Oh, right, we need to restart our server, I think. There. So now, instead of like getting each response one at a time, 15 requests come in, 15 responses go out immediately, and it's beautiful. And we might even be able to increase the number of requests that can come in. Maybe we can serve 150 requests all at the same time. Yeah, there we go. We sent 150 responses all at the same time with 150 threads. Great. So we have now we have a web server. And like, to me, when I think about a web server, this is what like sort of like the core structure I think about, right? Is like you have some sort of loop that's accepting connections. It's starting maybe a thread. It could be also a green thread, like some kind of more lightweight thread on event loop. But there does need to be something that acts like a thread at least, so that requests can be processed in parallel. Like in Node, for example, you don't actually have different threads handling your different requests, but they do need to run concurrently and like interleave with each other on the main loop, on the event loop. All right, what else do we have to do? We could do step 4, where we look at the HTTP request. I think that could be fun to do really quickly. All right. So maybe instead of saying hi there, we could say hi to, like, we could do something which is like curl localhost 8080 / like Julia or something. So if we do that right now, we'll just get the response hi there, which makes sense. But what if we wanted to be like, hi Julia, right? As if we were writing a real web server with real code. So let's do that super quickly, and then we'll be done with this very silly web server. So we need to get the request out. So here's our request, and then maybe I'm gonna do something hacky because I don't want to write a whole like parsing library just to make this silly web server. So what I'm gonna do is I'm gonna put the Julia, like the string that we're gonna like put in our response, between 2 slashes, just to make the parsing easy. So we're just gonna try to split this on a slash, and maybe just print that out so that we can see what we're getting. This is going to be extremely hacky. All right. So the string we want to put into our response is, it looks like the second thing when we split. So we can just say name. This is the name, and then we can just say HTTP response.replace name. And let's see if it works. Oh yeah, I need quotes around that. Everything needs to be bytes. Everything needs to be bytes. I think there's an ongoing theme here, which is that I keep on forgetting to make everything bytes. Oh wow, it says hi Julia, and then I could make it say hi Bob, or hi Anya. Amazing. And you see there's kind of an extra, what if we do this? Yeah, so this gets truncated here because the content length is actually wrong. So because we hard-coded content length to 10, and the content length needs to be the actual content length of the response. So I guess we can fix that up really quickly. No, I don't feel like doing it. But basically, we would just like set the response to hi, this thing. We would get the length of that. We would put that in the content length header. And then we would put that string at the end, and then we would reply with it. But that was kind of a fun thing that goes wrong, which shows you that the content length actually does have to match. Actually does have to match what's in your body, which makes sense. And then if I go here, then I can get like, hi, Julia. So we've written a web server totally from scratch, and this was, as promised, 25-ish lines of code, maybe 29, and it's parallel. It has all kinds of different threads. You could make like, I don't know how many parallel requests you could make to it at a time. We could try, I guess. Like, what if we say I want to make 1,000 parallel requests to it? That's not that many. Will this work? No. It should work. I just want to use Apache Bench really quickly, which is a benchmarking tool that'll tell us like how fast it can make all these requests. So it's working. It's doing something. It says that some of these requests are kind of slow, which is kind of... Oh, it's because they're all waiting half a second. That's why. We should remove this time.sleep, because that's ridiculous. Yeah, okay. Beautiful. So once you remove the sleep, all of the requests got super fast, and the slowest request is 52 milliseconds. And if we increase this and we try to like... Oh, it didn't like that. Interesting. Too many open files. Interesting. So here it seems like some of my requests, like a very small number, have taken 2 seconds, even though almost all of them are very, very fast. So who knows? Anyway, Apache Bench is just this benchmarking tool that you can use to kind of like hammer a web server with requests and see how long they're taking. So that's all I had to say about writing a web server with sockets. I hope that was fun, and thanks for watching.